So the last section we started talking about some of those important names we need to know, like Democritus, who came up with the concept of an atom, Dalton, who came up with some of those early rules, and then J.J. Thomson, who actually was the first to discover an electron. We've got a couple more names we need to know. So Robert Millikan did something called the oil drop experiment, which is actually pretty cool. But what he did was he determined the magnitude of the electron charge. So J.J. Thomson actually discovered the electron. He knew it was negative, but he didn't know how negative or how much that charge was. Millikan's the one that determined that. He also determined the mass of an electron. Okay? So this should actually be a superscript. It's 10 to the negative 31st. But an electron is very, 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 very small. All of our atoms very small, but compared to a proton, compared to a neutron, an electron is so tiny. Okay? That's important to remember. You don't need to remember this number, but you need to remember that electrons are the smallest part of an atom. Okay? So then Ernest Rutherford came along, and he did something called the gold foil experiment. So what he did is he discovered the nucleus. So what he did is here we've got these alpha particles. Alpha particles are radioactive particles. They've got a positive charge. And he shot them at a sheet of gold foil. Now, what he expected is he expected that if an atom looked like this, that all of the alpha particles would pass right through. And so he expected this straight line like this. But not all of the particles went straight through. Some went off to the side, some went backwards, some came straight back. So what he realized is that those alpha particles had to run into something that was pretty big and had a positive charge. So that's what he called the nucleus. It has a big mass and it's positively charged. Okay? So when we talk about the atom now, we know that the nucleus contains both positive protons and neutral neutrons. When we look at the periodic table, we've got our element symbol. Element symbol has only one capital letter. If it has more than one letter, they're all lowercase. The mass number is the larger of the two numbers. And the mass number is our protons and our neutrons. Remember we said the electrons were so small, they're basically negligible, so we say they don't really contribute to the mass. The protons and the neutrons are pretty much the same size, so they both make up our mass. Atomic number is the smaller of the two numbers. It is only the protons. Now we know that in a neutral atom, which all of our regular atoms are, the number of positive protons and the negative electrons must be equal. So the atomic number tells us the number of protons, but it's also equal to the number of negative electrons. Okay? Now, protons are what they list on the periodic table, but that's not what determines reactivity. When we talk about reactivity, it's the number of electrons. Okay? So you need to remember protons determine what element it is, but electrons determine how it reacts. Okay? So remember when we were talking about Dalton, Dalton said all atoms of the same element are going to be identical. And we said that's not true because of something called isotopes. Well, what an isotope is it's an atom of the same element, so it has the same number of protons, it has the same number of electrons, but it has different numbers of neutrons. So the positive and the negative still cancel out. It is still a neutral atom. Neutrons have no charge, so the only thing that changes is how heavy something is. So for example, in the picture below, we have two isotopes of sodium. If you look, little number is 11 for both. Both sodium atoms must have 11 protons. Both sodium atoms must have 11 electrons. But the mass number is different. This one's 23, this one's 24, because this one has 12 neutrons, this one has 13. And the way I can figure that out, the mass is 23. The mass is my protons and my neutrons. So 23 minus just my protons gives me 12 neutrons. Same thing over here. I have 24 for my mass number. I still only have 11 protons, so I have to have 13 neutrons. Now, when we talk about isotopes, we call them by their mass. That's how we differentiate them. So these are both sodium atoms. I would call this sodium 23. I would call this sodium 24. Okay. So when we've got our atoms can be held together, and they're held together to form compounds. So two or more elements chemically combined are going to form a compound. Okay? We've got different types of compounds depending on the type of bond that forms. In a covalent bond, we've got two atoms that are going to share electrons. Okay? This is going to form between two different nonmetals. And then the term we use for the compound when it comes together, when they're covalently bonded, we call it a molecule. Okay? An ionic bond, on the other hand, is going to form between a metal and a nonmetal. So I have to have one of each. They're going to form ions. Now, an isotope is two atoms of the same element. Protons are the same, electrons are the same. We change the neutrons. An ion, what we did is we gave it a charge. And the way that we gave it a charge is we're going to mess with the electrons. Okay? So we've got two different types of ions that can form. A cation is going to have a positive charge. It's going to form when an atom loses an electron. Remember, an electron has a negative charge, so if I have less negative, my positive stays the same, so I've got more positive, so I'm going to have a positive charge. Okay? The positive cations are going to be formed from metals. Now the way I remember that cations have a positive charge is because a cat, meow, walks on paws. Okay? So cations are positive. Here's an example below. Sodium atoms have 11 protons, 11 electrons. They are neutral. To form a sodium cation with a positive 1 charge, it has to lose 1 electron. Okay? If you notice, my original atom is going to be larger than my cation because I lost an electron. Okay? So cations have a positive charge, anions have a negative charge. Cations are made from losing electrons. Anions are made from gaining an electron. Cations are formed from metals. Anions are formed from non-metals. So just like before, I've got my regular neutral chlorine atom. My chlorine atom has 17 protons, 17 electrons. It is neutral. It has to gain an electron. So you notice when I lost an electron, it was a product. When I gain an electron, it's a reactant. So chlorine's going to gain one electron to form a chlorine ion, an anion. It's going to be larger than the original atom because now I have more electrons. Okay? Now, when I combine positive cations and negative anions, I'm going to create an ionic solid. Okay? Now, I don't use the word molecule anymore because now I have this ionic compound. I can call it an ionic compound, an ionic solid, an ionic compound. Sometimes I'll just call it a salt. So table salt is an ionic compound. So is a bunch of other things. So when I say salt, it's not always just table salt. Okay. One last term we're going to talk about really quick is a polyatomic ion. A polyatomic ion is a group of atoms that have a charge. So up here, I have chlorine with a -1 charge, or sodium with a +1 charge. Poly is many, so here I've got nitrogen, I've got 4 hydrogens, and they all have a charge.